Welcome to Unit 3, Lesson 4, Introduction to Trigonometric Equations. So now that we are comfortable with all 6 of the trigonometric ratios, sine, cosine, tangent, and then cosecant, secant, and cotangent, we're going to be able to start doing some math with them. Now, this may seem daunting, but I just will give you some hints and tips throughout the lesson to hopefully make it a little bit easier for you. I just wanted to give you a reminder about the shape of the brackets. So when we have theta is an element of 0 to positive pi with rounded brackets, don't forget that if you were writing that out in this notation, that you would have 0 is less than, theta is less than pi. Whereas the closed bracket will give you that less than or equal to value. So to solve the equations using trigonometric functions, you're going to need to be a little bit crafty, and then you're also going to need to remember some stuff about each of the functions. Remember the ones that are related. Sine and cosecant are inverses of each other. Cosine and secant are inverses of each other, and tangent and cotangent are inverses of each other. If you start with that, that's a really good place. So, for example, we have these equations that we're going to solve, and I'll talk you through how to do it. Now, notice that this is in degrees, so we're going to be working in degrees. It's really, really important that you respond your answer in the correct format. So, treat the trigonometric function kind of like an x term if you were solving an equation. You're still going to be doing the same functions, moving things back and forth across the equal sign. Remember, whatever you do to one side, you do to the other, and you'll eventually work it down to a place where you have a value for that trigonometric function. So here we have 3 cosecant x minus 6 equals 0, and we're going to be between 0 and 360 degrees. Now, once that happens, what you're going to do is isolate a way to solve for cosecant x. So we're subtracting 6 here. We add 6 to both sides to give us 3 cosecant x equals 6. And then we're multiplying by 3 here, so we'll divide both sides by 3 to give us a final answer of cosecant x equals 2. What you need to recognize is that cosecant x equals 2, it's the same as 1 over sine x or sine theta. So if cosecant is 2, you just need to take the reciprocal of that to find sine x. And once you know that sine x is positive 1/2, all you need to do is just think about, well, at what locations is sine positive? Of course, it's in quadrant 1 and quadrant 2. And you'll be able to find your angles 30 and 150 degrees. So if we look at our unit circle, you can see our y-coordinate is positive 1/2 at 30 degrees or pi over 6, and also at 150 degrees or 5 pi over 6. We can also solve by grouping similar terms. So if you wanted to simplify this in your head, you could think of it as 5x plus 2 equals 1 plus 3x. So you have 2x terms and then 2 whole number terms, and you're still going to move them all to one side to solve and isolate that sine variable. Now notice this time our interval is in radians from 0 to 2 pi. So when you get your final answer, you're going to want to express it as radians instead of degrees. Step number 1 in this question, we are going to move all the signs to one side. So we're adding 3 sine theta here. You want to subtract 3 sine theta and move it to this side from both sides. I recommend moving this to the left as opposed to moving the 5 sine to the right, because then you'll keep working with a positive sine value and it will just uncomplicate things. You won't need to divide by -1 at the end. So we have 5 sine theta plus 2 minus 3 sine theta equals 1. Now, you can combine these terms because they're similar. 5 minus 3 is 2 sine theta plus 2 equals 1. And then just do your basic equation solving. Subtract 2 from both sides. So now we have -1 over here. Divide both sides by 2. Sine theta equals -1/2. Remember that sine is negative in quadrants 3 and 4. So your answer is going to be somewhere in that quadrant. What's really important here is that you recognize that the reference angle for this question is pi over 6 radians. So once we do that, we'll be able to find the angles for the solution to this problem. Now in quadrant 3, we're going to go pi plus the reference angle. So pi plus pi over 6 will give us 7 pi over 6 as one of our angles. And then in the fourth quadrant, we're going 360 or 2 pi, subtract the reference angle, which gives us 11 pi over 6. If you look at your unit circle, you can confirm that. Here you have your 7 pi over 6 sine, or the y coordinate is -1/2. And the same thing in the fourth quadrant, the sine of 11 pi over 6 is also -1/2. So you know you've done the question correctly. We can also solve for trigonometric ratios by factoring. So I just want to simplify it for you again. Just remember that the function is in the format of ax squared plus bx plus c equals 0. So look at the coefficients a, b, and c, and then add in the trig function as your quote x value. Okay, so here where we have tan squared theta, tan theta plus 4, it's in this format, tan squared theta, tan theta plus 4. So don't overcomplicate it. It's still really, really simple. When we factor out, you're going to get two possible values for tan theta. Sometimes both of them will work. Other times only one will work. So you have to be careful and check and reference both answers to see what results you can get. So when we factor this out, remember you're trying to find two numbers for your outside spots that add up to the middle number and then multiply out to give you the last number. So of course the factors of 4 are 1, 2, and 4. Our middle number is -5, so that's a pretty good indication that we're going to have -1, -4 as our factors. Once you have it in the two brackets, you can isolate each one out. Tan theta equals 1. Of course, before that, we would have had tan theta minus 1 equals 0. And then we just solve for tan theta. Or alternatively, tan theta equals 4. Or the angle tan to the -1, 4 is approximately 1.3 rads. With tan theta equals to 1, all you need to do is look at the unit circle and find where that occurs, and it happens at pi over 4 and 5 pi over 4, which are the quadrants where tangent is positive. So in quadrant 3, we also need to consider that tan is positive there. It's positive in quads 1 and 3. So once you have this reference angle 1.326, you can just simplify the rest of the solution to find what the value of that angle would be in quadrant 3, or 4.467 rads. Now, there's a difference between these solutions. Although they take you to the same place, the exact solutions we would be considering would be the ones that give us pi over 4 and 5 pi over 4 radians. Our approximate solutions, which we'd use the calculator for, would be 1.3 and 4.5-ish rads. There's an additional example down here where your ax squared value has a coefficient at the front that's something other than 1. So I just wanted you to see an example of that. So when we factor out this polynomial, what we end up getting is 2 sine theta plus 1 and sine theta minus 2. Now you kind of have to play around with where the 1 and the 2 go, because you need them to add up to -3, and this multiplier becomes a factor in this situation. So I'll just talk about what that looks like here by using the check. So once we have our two factors, we can just multiply it out to see if we end up with what we started with. That's how we would know that we did it correctly. Now, you have 2 sine theta times sine theta. That will give you 2 sine squared theta. And then you have 2 sine theta times -2, which gives you -4 sine theta. And then plus 1 times sine theta, which gives you plus 1 sine theta. And then, of course, plus 1 minus 2 gives you -2. When we combine them together, we get back to our original equation. So that's a good indication that we have the correct factors here. Now, once you have that, you're just going to set each of the brackets equal to 0 and see what values you can possibly get for sine theta. So I'll talk about the right-hand one first. We have sine theta minus 2 equals 0. Now, we haven't covered it in this course because it should be prior knowledge that you have, but the value of sine cannot exceed positive or 1 or go lower than negative 1. So if you get here sine theta equals to 2, then it becomes an undefined function and it won't exist. So this solution is not valid, and then we just need to consider the other side. On this side, we have 2 sine theta plus 1 equals 0. Of course, we're going to isolate sine theta, so subtract 1 from both sides, negative 1, and then divide both sides by 2 to give us negative 1/2. Now that we know sine theta is equal to negative 1/2, we just look at our unit circle and find that theta is equal to 7 pi over 6 or 11 pi over 6. So just a reminder again, these functions, they're in this format, ax squared bx plus c equals 0. Don't get thrown off by the function being there. It just represents your x value. You're still just solving for x. We also have a general solution of trigonometric equations. So here's an example. Determine the values of x in the range of 0 is less than or equal to theta is less than 2 pi, which verify that the equation sine squared x minus 1 equals 0 give the exact values. So there's 2 different methods that you can use. You can either use square root principles. So just find the square root of this term, the square root of sine squared x equals 1, of course, will give you positive or negative 1. And then you can just confirm those values using your unit circle. This is a really simple way. If it's clean and cut and one of the values that ends up on the 3 points that you're kind of referencing on the unit circle, then it becomes really simple and straightforward. If not, you can always use factorization to help you to solve for that. So the exact same way that we solved for it before, you just break it down into 2 factors, sine x minus 1, sine x plus 1, and then check using that left-hand side, right-hand side model to make sure that they're equal to each other to verify your answers again. So of course, if left side equals right side, then you know your answer to be true, which in this case, both of them are. Both solutions are possible, negative 1 and plus 1. But just like the previous question we did, you want to check both sides to make sure that they both work. Don't assume that just because one works, the other will, because that's not always the case. We can use a general solution of sine squared x minus 1 once we know and have verified our coordinates. So we know that we have a value at pi over 2 and 3 pi over 2. Now, don't forget that we have unlimited coterminal angles by adding or subtracting 2 pi radians or 360 degrees from our values. So once you've found this, you can have unlimited answers in either direction as long as you're adding or subtracting 2 pi, which is a full rotation. So once you have that, angle pi over 2, we can use this general formula. X is equal to pi over 2 plus 2 pi n, where n is any integer. So that would be a whole number with a positive or negative sign. So you can see here, just like up top, you can get a variety of coterminal angles. The same is true for the other angle as well. So once you have that solved, you'll be able to come up with a general function for that and just recognize that rotations around the unit circle equate to 2 pi. On the back side of this page, things get a little squirrely and they look pretty crazy, but I want you to just take a deep breath and kind of lean into this learning. It's probably unfamiliar for you, but it's actually super simple once you break it down. I found a really good resource app that you can download on your phone. It's called Mathway. And for this section, if you click into the trigonometry area, you can actually type in the question that you're trying to solve, and it will give you a worked solution step by step for free. So that's a really nice resource to have. I will caution you, however, don't lean on it. Do your best to solve it without that and maybe just use it to verify your answers because you will not have that technology in your assessments. So make sure you understand the principles behind it, and this app will give you a really good explanation on how to solve the problem. But make sure in your heart you know how to do it, because that will be the true test of your abilities. So let's just talk about these questions. We have this value cos 1/2 theta equals 1/2, where theta is an element of real numbers. So what we're trying to do is figuring out what is the angle. In this circumstance, what we want to do is substitute 1/2 theta equals x. So we're going to put x in this value here. So we have this cos 1/2 theta equals 1/2. Instead of writing that, we're just going to simplify it and write x and find the values on the unit circle that correspond to that. So we know that cosine is positive in quadrant 1 and quadrant 4. So once we know that cosine is equal to 1/2, then we get these two solutions. So I'm just going to talk about both of them at once. We have this general solution that we just covered in that previous example. X is equal to pi over 3 plus 2 pi n, where n is an element of z or any positive or negative integer. So what we want to do is figure out specifically what is the coordinate of theta. Now don't forget, if we go back to the start of the question, we have cos 1/2 theta equals 1/2. And we want to solve and figure out what is theta. So we need to isolate that theta term. And I want to remind you again, don't forget that whatever you do to this side of the equation, you also need to do it to this side. So if we treat all of this like it's in a bracket, we'll just include it as a term. This n is an element of z or any integer. Don't forget that that is just giving you the parameters of your values, so nothing will happen to that. It's actually not part of the mathematical equation. So here we have 1/2 theta. We want to cancel out that 2, so we're going to multiply by 2, because 2 divided by 2 of course is 1, so all we'll be left with on the left hand side is theta. Because we multiplied this side by 2, we also need to multiply all the terms here, pi over 3 and 2 pi n, by 2 as well, and then we'll get the true value of our angle theta. So theta is going to be equal to 2 pi over 3 plus 2 times 2 is 4 pi n, where n is any integer. Okay, so that's one value of it. This is in quadrant 1. In quadrant 4, we're going to do the exact same thing. We're going to have 2 times 1/2 to cancel out the 2's. We're just left with theta on the left hand side. Because we multiplied by 2 here, we're going to multiply this side by 2 as well. So we have 2 times 5 pi over 3 gives us 10 pi over 3. And then 2 times 2 pi over n gives us, and then 2 times 2 pi n will give us 4 pi n. So our two angles here, quadrant 1 and quadrant 4, are 2 pi over 3 and 10 pi over 3. Notice that this angle, x pi over 3, is 1/2 of our theta. Here's 1/2 theta. It's asking for cos 1/2 of the angle. Here we have 2 pi over 3, and the angle that we use to find the 1/2 is pi over 3. So don't be afraid to substitute that x in to simplify and solve for it. In the second example, we have tan theta plus cos theta times tan theta equals 0. This might look like gibberish to you, but we can break it down into its elements and actually solve for sine theta at the end. So tan theta is of course equal to sine theta over cos theta. Typically, whenever you have tangent or cotangent, you're going to want to write it in the format sine over cos or cos over sine if you have cotangent, so that you can see the parts. It makes it easier to work with the rest of the equation, and it becomes evident in the very first step. So we have sine theta over cos theta plus cos theta times sine over cos again equals 0. Now, Cos divided by cos is, of course, 1. So all we're left with in this term is sine theta. And now we have sine over cos plus sine equals 1. Here we're going to do that substitution again to make x into sine and have cos as your independent value that we're kind of solving to get rid of. So we have x over cos theta plus x equals 0. And then we're going to divide x out of this whole term. So once we've divided the x out, we're left with 1 over cos theta plus 1 equals 0. What we can do now is divide both sides of the equal sign by this whole term to cancel it out. So if we divide 1 by 1, of course, it just becomes 1 and disappears. And then on the right-hand side, when we complete that same task, we have 0 over it doesn't matter the value of this because the top of the fraction is 0. So we know that x equals 0, and we said that x is equal to sine theta. So sine theta is 0, and that's our y coordinate. So just keep in mind that our y coordinate is equal to 0 here and here. So basically, your response will be that your theta is equal to pi times n, where n is any integer, because you'll have a response at every pi, 0 pi, 2 pi, 3 pi, all the way off to infinity and beyond. So the last example that we have, determine the solutions of the trigonometric equation 2 cos squared x minus 1 equals 0 in the interval 0 to 360 degrees. So the same thing here, we're just going to isolate that cosine value and try and solve for it. So think of this 2x squared minus 1 equals 0 and just solve for x. So 2 cos squared x equals 1 by adding 1 to both sides. And then we're going to divide both sides by 2. Cos squared x equals 1/2. Okay, we don't want cos squared x, we want cos x. So we're going to take the square root of both sides. That will leave us with cos x on the left-hand side and root 1 over root 2 on the right-hand side. Don't leave it in this big square root format because it's not clear what's happening to the numerator and denominator. Break that radicand into 2 so that you can see what you need to do next, which is multiply top and bottom by root 2 so that you get the radical number on top. So of course the square root of 1 is 1 times root 2 gives us root 2, and on the bottom root 2 times 2, root 2 gives us positive 2. Now, in your answer, the question asks you for the interval 0 to 360 degrees. That tells us that cosine can be either positive or negative. So you need to consider all the situations where cosine is equal to root 2 over 2, whether the value is positive or negative. So in this question, we actually have 4 answers, and we'll have an answer at x equals 45 degrees, 315, 135, and 225. So of course this represents the positive values of root 2 over 2, and this represents the negative values of root 2 over 2. Beyond this, you have some practice questions. I encourage you to really give it a good go, and don't forget when you're presented with something like this for secant x, don't forget that that's 1 over cosine x. That will help you to start solving it. And once you finish those practice questions, you'll be ready to do the homework on this topic.